Hey everyone, and welcome. Today, we are diving straight into the Python programming language. Now, this isn't going to be some dry, formal lecture. Think of this more as an informal tour, a hands-on look at the most basic building blocks of Python, using the official tutorial as our roadmap. All right, let's roll up our sleeves and actually start playing with some code.
You know, the best way to get a feel for any new language is to just start typing. And Python makes this super easy. You can use its interactive interpreter just like a simple calculator. There's no complex setup needed. You just type something in and you get an answer right back. It's instant feedback. So check this out. You can type in a totally normal math expression, just like you would on a piece of paper. You type 50 minus 5 times 6, hit enter, and Python just does the math. It knows the order of operations, does the multiplication first, and boom, it spits out the answer, 20. This immediate back and forth is perfect for just trying things out and seeing what happens. Okay, here's our first little aha moment about how Python thinks. When you use a single slash for division, like 8 divided by 5, it always gives you back what's called a float. That's just a number with a decimal point. Even if the number is divided perfectly, you'd still get a decimal. It seems like a tiny detail, but trust me, this design choice prevents a ton of common bugs you run into in other languages. A calculator is fun and all, but for a real program, we need it to remember things. And we do that with variables. All the equal sign does is give a name, a label, to a value. So here, width becomes our nickname for the number 20. And now we can use those names in our calculations. This right here is the moment we stop being a fancy calculator and start actually programming.
So, we've got numbers down, but what about words? I mean, programs have to deal with text and sentences all the time, right? Well, in Python, the building block for all text is something called a string. Let's see what we can do with that. And here's where it gets kind of cool. You can use operators you already know, like plus and multiply, but they do something totally different with strings. The plus sign glues them together. We call that concatenation. And the multiplication sign, it just repeats the string. So as this great little example shows, you can literally write 3 times un plus em and get ununium. It's just really intuitive.
Now, this visual perfectly illustrates one of Python's most powerful features, slicing. The absolute best way to wrap your head around this is to imagine that the numbers, the indexes, aren't pointing at the letters. Instead, they point to the gaps between the letters. So index 0 is the space before the P. Index 1 is the space between P and Y, and so on. If you think of it like you're making cuts, it makes perfect sense. So using that cutting idea, let's see it in action. We've got our word, Python. If we want to slice from position 0 to 2, we write word 0/2. Now here is the one rule you have to remember. The starting number is always included, but the ending number is always excluded. So word 0/2 gives you the slice between cut 0 and cut 2, which is pi. And if you leave out the last number, like in word 4/, Python just assumes you mean go all the way to the end.
Okay, so we have numbers, we have text. But what if you need to group a bunch of things together? You know, like a list of names or a list of scores. For that, Python gives us our next core building block, the list. Seriously, just think of it like a shopping list for your code. It's a flexible container that holds your items in order. Okay, get ready, because this is a huge aha moment when you're learning Python. Strings and lists, they look kind of similar, but there's one massive difference between them. Strings are immutable. That's a fancy word for can't be changed. Once you make a string, it's set in stone. If you try to change a letter, like swapping P for J, Python gives you an error. But lists are mutable. They're designed to be changed. Look at this list of cube numbers. Oops, 65 is wrong. No problem. We just target that spot, index 3, and assign the correct value, 64. Understanding this difference is absolutely key.
So because lists are changeable, they can also grow. And the easiest way to make that happen is with the append method. It's super straightforward. You just take your list, in this case cubes, and you tell it what you want to append. The new item just gets tacked right onto the very end of the list. It's as simple as that.
All right, let's take a breath. We've looked at numbers, variables, strings, and lists. We have all of our basic building blocks laid out on the table. So now it's time for the payoff.
Let's put these pieces together and build our very first actual program. We have all the parts we need. We've seen how they work on their own. So, are you ready to see what happens when we make them work together?
And here it is, a tiny but complete program that generates the famous Fibonacci sequence. First, we use this neat Python trick called multiple assignment to set A to 0 and B to 1, all in one go. Then, we hit this while loop. This is the engine of our program. It says, as long as the variable A is less than 10, keep doing the stuff inside this block. And inside, we print A, and then, here's the magic. The line A, B equals B, A plus B does two things at the exact same time. It updates A to whatever B used to be, and it updates B to the sum of the two old values. It's an incredibly slick way to handle the logic.
So, you're probably looking at that loop and wondering, how does Python know which lines are inside the loop? The answer is indentation. See those spaces at the beginning of the print line? That's not just to make it look pretty. That is a fundamental rule of the language. In Python, indentation is how you group code together. It's not optional for style. It's how the language itself is structured. And it's a huge reason why Python code is famous for being so clean and readable. And there you have it. We went from using Python as a simple calculator to working with text and lists, all the way to writing a real program with a loop. These are the absolute fundamental building blocks you'll use everywhere in Python. You've officially taken your first real steps. The only question left is, what are you going to build next?